Record. Okay. Hi, Vian. Hope you're doing well at home. This video is for you, so you can watch this while you're at home. We're going to cover 14H today. We're going to park 14G, which is about sketching graphs, and we're going to do 14G and I and J as a group because that focuses on graphs. We'll focus on solving for trigonometric equations first, so that you actually have a good idea of how to find the x-intercepts when it comes to sketching graphs, okay? Now, with 14H here, we do need an understanding of all the exact values, okay? Because this is where we start to use the exact values, okay? But we have to work in reverse. So instead of saying, okay, I have to put down my pi on 4 finger, or I have to put down my pi on 3 finger, in this case, we actually got to ask ourselves, okay, which finger do I have to put down to get sine equals 1/2? Okay, so in this case here, we're solving for theta between 0 and 4 pi. There's a process to this, so I'll walk you through the process. We need 2 base solutions first, and every time we do solving, we need to draw out the unit circle, okay? So with sine equals 1/2, if we want to solve for theta, so here's our question. If you're writing this in your book, write this out like so, and I'll put a comma that theta is between 0 and pi on 4 pi, sorry. It says find all the solutions. So what are the solutions? We're solving for theta, okay? When we solve for this, we take sine inverse to the right-hand side. It becomes sine inverse. Sine inverse in this case. Now, we notice here that we have 1/2, but I'll just put a little note here that it's a positive 1/2. And this is where the unit circle comes in. So I'm just going to stash away a unit circle here. Put this on the side, but I'll duplicate this here. So we've got a unit circle, and we need to figure out where sine is equal to 1/2. What does sine measure again? The y. So the y value is 1/2. So if you have a look at the y-axis, here's a value of 1/2 here. We need to find out the points on the unit circle that gives us the angles of 1/2. So tell me when to stop. I'm going to pivot. Stop. Okay, so there's one of our angles, right? But also in the unit circle, if I keep going, I can also reach a y value of 1/2. Stop right there as well. Now we actually need to find out what those values are, right? What the angles are. So I need to know this angle here. And I need to know what this angle over here is as well. Okay, so there's 2 solutions. Again, I'll ask you, what quadrants do these angles land in? Instead of saying 1 and 2, we can say A and S. Whoops. A and S, okay? So that we know that it's going to give us a positive 1/2. Okay? Now we've got to figure out which finger we need to put down. So, and on our hand, and for those at home who can't see, we've got 1, 2, 3. We've got our 5 fingers and a quadrant number 1. Which finger would we put down so sine is equal to 1/2? Which finger? Yep, the ring finger. The ring finger. So we're going to put down this finger here. Okay, which finger was this finger that we just put down? Pi on 6, correct. This is the answer here for your unit circle. Okay, so our angle is pi on 6. That's the finger that we put down. So what does this mean? These two angles here are pi on 6. And this one over here is 5 pi on 6. Fantastic. So I see 6 pi on 6. And I go back by pi on 6. All right. And just keep in mind that that's pi there. Now, I just want to add in a little bit extra as well. Do you want to come sit at the front? So you're not so far. The other thing as well is like, I'm going to go between negative pi to pi, okay? Why do I choose negative pi to pi? Usually we would go from 0 to 2 pi for our base solutions. But going negative pi to pi makes it easier because the numbers are between -1 to 1. Okay? So it's either just going to be the positive up to 1 pi, or in the negatives down to -1 pi. Okay? This is setting you up so that once we get to general solutions, it works easily for you. Okay? So this is just, I'm planning ahead here for you. Okay, so we've got the unit circle up so far. We've found out where our angles are. This means that we've got two base angles. We've got two base angles. First one is pi on 6. The second one is 5 pi on 6. However, notice that I put the dot, dot, dot. The dot, dot, dot here means that these are the only two base solutions. But if I actually want to get back here, I can continue to rotate around the unit circle. If I rotate a full revolution, I get back to the same spot. Right? If I rotate another full revolution, I get back to the same spot. And I can keep on winding and winding and winding, and I'll get back to the same spot. So we know that we can keep on repeating, and we'll go around the unit circle an infinite amount of times, right? So we can basically keep repeating. We can go forwards, and we can also go in the negatives as well, rotate the other way. So this is only our two base solutions. There's an infinite amount more. That's why there's the dot, dot, dot. So we've only found two solutions between 0 and 4 pi. There are more that exist. If we want to get to the next set of solutions, we need to add on a full revolution, right? In this case, the full revolution is called a period when it exists from one section to the next before it starts repeating the pattern again. So we're looking at patterns here, yeah? So how long does it take for us to get back to the same spot, or how far? 2 pi. Okay. Now, there's a rule here for this section. Once we get up to our two base solutions, the next thing we have to find is our period. So our period is calculated by 2 pi over n. The n value is at the front where the variable is. So I'll label that in as well. That's where n is. What's our n in this case? 1. So 2 pi over 1, which is just 2 pi. Okay, which is what you said. And you can see it here visually as well. If I want to get back to the same spot, I need to go by 2 pi. Same with 5 pi on 6. If I want to get back to that same spot, I need to add 2 pi as well. Now, okay, so how do we get our next solutions then? How do we get the next one up? Because there's more solutions, right? So here's our first one. Here's our second one. If we continue around the unit circle, are there any solutions down in the bottom half? Nope. But what happens if we go all the way back around now? Which one do we hit first? Pi on 6, but it's no longer pi on 6, right? So here's our first solution. We've got that first one, that's pi on 6. We continue around the unit circle. That's our second solution. And here's pi, yeah? How many times do we have to rotate to get to 4 pi? 2 whole revolutions, right? So here's 0 pi, 2 pi, one more, that's 4 pi, right? So how many solutions should we have? 4 solutions, right? 1, 2, 3, 4, stop. Does that make sense in terms of our domain? Okay, so we've got 2 more solutions. We've got to land back at this one here. So how do we get to the next solution? We need to add 2 pi onto it. So you'll notice, and I'll map it out. Now I've got to add pi on 6. I've got 5 pi on 6. My next one is pi on 6 plus 2 pi, yeah? What's the next one after that? Correct. Now, writing it like that is so that you can see it, right? And then after that, we stop. Because we don't want to go further. Now, doing it like this, though, is annoying because what do you notice? We have to add the fractions, right? What would make it easier for us? Should we express it as 2 pi? 12 pi on 6. Okay, so we're going to modify this period and write it as 12 pi on 6. Reason being is because it's same denominator. And I'll do something else as well. Notice the domain at the top. I'm going to modify it as well, so it's the same as pi on 6 as well. So that's the same as 24 pi on 6. If I multiply the top by 6 and the bottom by 6. So you can see now there's 3 things that have the same denominators. Okay, we've got the domain, we've got our base solutions, and we've got our period as the same denominator. Now, instead of doing this line is optional, yeah? This is just so you can see, this is optional here. In fact, when I do working out, I don't write this line down at all. But write it down so that you know. The way that I do it is I'll start off, okay, I've got pi on 6. I've got 5 pi on 6. Now I slinky forward. I slinky forward by adding pi on 6 to, I add 12 pi on 6 to the first solution. Sorry, I'll zoom in here. That brings us to, what's pi on 6 plus 12 pi on 6? 13 pi on 6. Notice how the denominators are the same. It's way easier to add. And I will slinky forward from the previous one. So what do we get for this? 17 pi on 6. How do we get the next solution up? Notice the pattern there, we're weaving. I like to call it the slinky effect. You know what a slinky is? How the spring, how it goes bounce and then swings over and swings over and swings over. Or you can call it a braiding effect when you braid your hair. Okay. The next one up is, what's this? 13 pi on 6 plus 12 pi on 6. 13 plus 12 is 25. However, do we want 25 pi on 6? Why not? Right. Notice it's easier to see your domain as 24 pi on 6 instead of 4 pi. Does that make sense now? Is it here? How'd I get 2 pi? The period here. And you have to actually look at what your n value is. Okay? You have to look at where your n value is for your period. So the rule is 2 pi on n. 2 pi on n. And so that's how you get 2 pi. All right? 2 pi on 1, that's 2 pi. But I don't want to express it as 2 pi. Let's have a look. If I want to get back to the same spot, I have to go a full revolution. That's 2 pi. Yeah, more visually, yeah? So for our final solution here, we don't want this last one because that's beyond the domain. Yeah, so that one is out. That's beyond the domain. This here, I'll give this here 2 marks, which is why you need to work fast. And this is why you need to be fluent with this section here. When it comes to sketching graphs, that would just be part of the process. This is part of finding your x-intercepts. That's all. Okay. Another question? These 4 solutions here. Yep. That's our 4 solutions there. So to recap, find your 2 base solutions using the unit circle. Find your period. And then add or subtract until you get to your final answer. Step 1, find your base solutions. Step 2, find your period. Add the period or subtract the period until you get to your domain. Okay. You can write those steps down when you listen to the recording again, which I hope you do. This here, we just do it on the CAS. Okay. So menu 3-1. So you go solve, comma X, right? But then you got to put in your domain as well. So how would this look on the CAS? Solve sine X equals negative 0.3, comma X, because that's what we're solving for. Given that, like so. You want to pop this in your notes. Because I rather you solve I'd rather you learn how to solve the ones by hand. No. So can you try this on your CAS? Make sure it's set in radians, by the way, on your CAS calculator. Make sure it's set to radians. And for this one here, we probably want to change it to degrees. Do you know how to change between radians and degrees? Wait, which ones? Notice where the given that symbol is. Is it inside the bracket or outside the bracket? Details matter. Yes, Arish. The given that symbol, control equals. The control button and the equals button are just underneath each other. So I want you to see here on the CAS, you want to make sure that your CAS is in radians, okay? So this is for the first question because it's in radians. Sine of X. So menu 3-1, we're solving for sine of X equals to negative 0.3, comma X. So given that, I'll just go control equals 2 across 1 down. Given that 0, control equals, I'll go to this one here. X, control equals again, and 2. Instead of writing pi, like the symbol, you can just go 2 pi. pi. Sorry, greater than symbol, control equals as well. Once you press enter, notice it'll give you that, but you can go control enter. What quadrant is this in? If it's pi plus that little section. The C quadrant? Where's pi? On the left, yeah? If you add.
Yeah.
Third quadrant, which is the T quadrant. And where's this? 2 pi minus. So 2 pi is on the right, you minus, you go clockwise. Negative is clockwise. So you land in the C quadrant. Okay. T and C. What is sine measuring? The Y, what's the Y value? Negative 0.3. The Y value is negative in the T and the C quadrant, isn't it? Because it's a negative Y axis. So you see the solutions here. These are, what does X represent? Not quite. The angle. Yes, I heard the angle. So X in this case is the angle, because have a look, sine at what angle, right? That's what we're trying to find out. Now, the second question is in degrees. So have a look up here. If you have the blue calculator, you should be able to go up here with your cursor and click it. It'll change to degrees. And you type everything in again, cos of X equals to negative 0.7 this time, comma X, given that X is between 0 and 360 degrees. Notice everything's in degrees at the moment. I didn't need to put in the degrees symbol. If I press enter, our answers will be in degrees. Okay. Now you can change this here manually if you go into settings. Sorry? What was this set in? What was the, it was set in radians, yeah? So these values here are in radians. So that's 3.4 radians. This value here is 6.0 radians. Whereas down here, we changed our settings to degrees. This is 134 degrees, 225 degrees. Okay, so you have to be very careful. Usually I leave it on radians, unless if it's talking about degrees. Okay. You have to be careful with that. So when you check out your answer at the back of the book and you find something different, then you got to check. That's the first thing I ask you to check. Is it in degrees or is it in radians? Okay, let's go back to calculating it by hand. So that was doing it by the CAS for a bit. We'll go back to doing it by hand now, because we need to develop that skill so that you can sketch graphs more easily. I'm not going to do the degrees one. I'm going to focus on this part here. I need a unit circle. Okay, I'm going to write down the question first. Sine of 2 theta equals root 3 on 2. Negative this time. And our angles are between negative pi and pi. First thing, we need to find our base solutions. Okay. Our base solutions. Now, what's the first thing that we take across to the right-hand side? Sine? Yeah, in the question here, we take across sine. So 2 theta equals to sine inverse of negative root 3 on 2. Bless you. Once you get here, you need the unit circle. Just sketch up the unit circle. I might even just do it here. What is sine measuring? Y. What's our Y value? Negative root 3 on 2. What's that roughly equal to? Negative 0.8 something. So it's down here. That's where negative root 3 over 2 is. So we need, how many solutions will we have? Tell me when to stop. Stop. Sorry, there. Because this angle gives me a Y value of negative root 3 on 2. Yes? But there's another one. Tell me when to stop. I want a Y value of negative root 3 on 2. Okay, cool. What quadrants did we land in? C and T. C and T. Notice that we were calculating sine. We landed in the T and the C quadrant. We expect to get a negative value. Okay. Now we actually just got to figure out what these angles are. Okay. What angle do you reckon it is? Sorry? Do you reckon it's pi on 4? Which? On the base angle, 0.345. Okay. We've got base angle first. So which one's the base angle? 0, pi on 6, pi on 4, pi on 3, pi on 2, yeah? Pi on 3. But I'm going to say here that I want your angles between 0, negative pi, and pi. So if I talk about 4 pi, then that's going to be incorrect. You can use 4 pi if you want. But I'm gonna strictly put it so it has to be between negative pi and pi. So 4 pi is correct, and 4 pi and 3 is correct for one of them. But I don't want it between 0 and 2 pi, yeah? So in this case, to land these values here, we need to go, instead of forwards, we don't want to pass pi. We don't want to move past here. We want to go backwards instead. Why? Because I just said we want our angles between negative pi to pi. Yeah. Negative pi to pi. Instead of 0 to 2 pi. Okay, we don't want that. So do you understand why we pivot backwards? Because our angles have to be between negative pi to pi. That's a standard, yeah? If you ever go into university and do Calc 1, Calc 2, that's basically specialist maths. We would need it between negative pi to pi. Okay, so we know our base angle is pi on 3, but now we got to pivot, right? So which one's this angle here? We pivot from 0, negative pi on 3. And for this angle here, we're at negative pi, we pivot forward. Negative 3 pi on 3. Negative 2 pi on 3. Those are your two base angles there. So we've got now, from this section, it comes down and becomes 2 theta equals to negative 2 pi on 3 and negative pi on 3. Numerical order, yeah? Negative 2 pi on 3 is more negative. Okay. What do we have to do now? Before I write the period, I'll move the 2 to the other side, right? So theta equals 2. And this is one of the few times that I'll actually discourage you to simplify. What would happen if I simplified this? You've got pi on 3 and pi on 6, yeah? Negative pi on 3 and negative pi on 6. The issue here is that the bases or the denominators, yeah? The denominators are different. It's harder to work with. Simplify at the end in this case. Okay? So now we've got theta by itself now. These are our two base solutions. I divided both sides by 2. All right, because we wanted theta as our final solution, yes? What's our period then? Dividing is the same as multiplying the denominator. Yeah? Dividing is the same as multiplying in the denominator. So I've just multiplied the denominator by 2. Okay, what's our n value up here? 2. What's our rule for the period? 2 pi over n. So what's our period? 2 pi over, what is our n? 2, which is equal to pi. But do we want to write it as pi? Same denominator as everything else, yeah? 6 pi on 6, okay? Because we want our denominators as the same. Where else should we change our denominators? On the domain at the top as well, okay? So at the top here, I'm going to change negative pi to negative 6 pi on 6 and positive pi to positive 6 pi on 6. Now that we've got all of our ingredients, what's our first solution? Yep. I'm just going to grab this here. This down the bottom. So we start with our first solution, negative 2 pi on 6. Our next solution is negative pi on 6. What's our next one forward? Four pi on 6. Do we need to go one more solution forward? Check it anyway. Negative pi on 6 plus 6 pi on 6 is? So is that still within the domain? Should we go one more forward? What's the next one forward though? That's 10 pi on 6. That goes over this. Now, what happens if we go one backwards? What do we get to? Is it negative 8 pi? We need to subtract from slinky backwards now, yeah? What does that become? Negative 6 pi on 6 minus pi on 6. Negative 7 pi on 6. Is that within the domain or outside? That's beyond the domain. So negative 7 pi on 6 and 10 pi on 6 all the way on the right should not exist. So therefore, those are our only solutions. Okay. But remember, we didn't simplify, so now, but you can see like it's in sequential order, yeah? -2, -1, 4, and 5. But now we have to simplify. And this is in sequential order. Yes? Sorry, which one? If it's not in order, you'll still get the marks for it if it's not in order. But say, for example, when it comes to sketching the graph, you're putting yourself at risk for not labeling it in order. True? Okay, so for the rest of today, I'm just going to do questions on the board regarding this. You need practice with this. Okay. So I'd like you to do a couple of questions from the textbook. Don't worry about 3. Leave 3 for now, right? I want you to try questions like question 4 and question 5 and questions 6 and 7. 5, 6, and 7. 4, 5, 6, and 7. 1, 2, 3. And this one here would be by the CAS calculator, yeah? Okay, use your time effectively. Speak with each other, work with each other. You don't have to just sit here, you can sit in groups as well. Right. The second one was pi and 3. You can do, if you look, observe, right? You can see that that's an angle of pi and 3. But the other way is, okay, I've got sine inverse of √3 on 2, right? If I want to use the hand method, 1, 2, 3, I want sine, that's sine, yeah, to count 3 fingers because it's √3 over 2, right? So I've got to put down, I've got to have this finger up, this finger up, this finger up, and this finger down. That's your pi on 3 finger. That gives me √3 on 2 for sine. Does that make sense? So instead of asking, okay, which finger I have to, like, instead of saying, okay, I have to put my pi on 3 finger down, this is reverse, right? It's saying which finger do I have to put down to get √3 on 2. Right, but that only gives you your base angle. You have to consider if it's positive or negative. Okay. So let's do some questions. Let's study together. Sorry? Yes, please, but you can use the CAS for that. Okay, without using a calculator, find all the values of x. We need to find all the values of x between 0 and 2 pi. So find all the values of x between 0 and 2 pi. If we were to do transitivity analysis, that's our circumstance. So, sorry, not theta, it's x in this case. You can write x is an element between 0 and 2 pi. Like so. Or you can write, if you prefer, this is different ways of writing the same thing, domains. For each of the following. Okay, so we've got this here. Whoops. I wrote the question correctly. My bad. First thing we take across in this case. 2 first. Then we take the cos across. As soon as you get the inverse, draw the unit circle. Now, I know before I had perfect ones, but I'm just going to draw this roughly. I'm going to actually find out what my base angle is first. So if I had my hand up here, 1, 2, 3, whoops. I'm calculating cos. So cos counts towards the x-axis. And I want √3 on 2. So I want to count 1, 2, 3 fingers. 1, 2, 3. Which finger did I put down? This one, which is pi on
6.
Yes, 6. 1, 2, 3, 4, 5, 6. That's why this one's pi on 6. That is correct. Cos of √3 on 2 is pi on 6. So notice here, I write pi on 6 on the side there. Is this a positive √3 on 2 or negative √3 on 2?
Positive.
Positive. Which quadrants should I land in? So it's positive. So cos is positive. A and C for cos, right? Once you've got that, all you have to do is pivot up by pi on 6 and pivot down by pi on 6. And since your angles are between negatives pi and pi, the two angles will be positive pi on 6 and negative pi on 6. Sorry? Which one?
No. 0. So you know how you said it's between pi and negative pi?
Yes. Pi and negative pi, because when it comes to general solutions, which is an infinite amount of solutions later on, you're going to do, you have to have it like a small fraction. See how this is a small fraction? You could write 11 pi on 6 if you wanted to. But see how the number's bigger? The number's 11, yeah? That's way bigger. Whereas 1 pi on 6 is, negative 1 pi on 6 is the same effect. The numbers are smaller, it's easier to manage. Does that make sense? Which one's easier to look at? Negative pi on 6 or 11 pi on 6? Yeah, that's why we do it between negative pi to pi. So our two base solutions will be negative pi on 6, because that's a smaller one, and pi on 6. Do we need to solve anything first? Do we need to put anything across? Yeah, so that's fine. The next thing we need is our period. That's 2 pi on n. N at the top here is just 1. But we want to express that as 12 pi on 6. I'm just going to rewrite the domain as well. So 0, I'm just going to modify it up here. 0, 12 pi on 6. Okay. So now we can write our solutions and then just bounce forward. Negative pi and 6. Do you want negative pi and 6 though? No, we don't. Yeah. We've got to bounce forward now until we get there, because you can see here, negative pi and 6 out of the domain. How do I get 12 pi and 6? So have a look at this, all right? You know how to get your period? Right? Why did I choose 12 pi and 6 instead of over something else? Yeah, look at your base solutions. Your base solutions dictate which fraction you need. In this case here, we need a pi on 6. Pi on 6 is good. Sorry? So this is 2 pi over 1, yeah? Multiply the top by 6, multiply the bottom by 6. That's how we get 12 pi and 6. Same fractions, yeah, this is fraction work. Equivalent fractions, year 7. Now we got to slinky forward, right? We're going to braid. To get it to our next solution, we add 12 pi and 6. So that's 11 pi and 6. Do we add one more forward? I'll do it anyway. So, yeah, plus 12 pi and 6. That gives us 13 pi and 6. So out of these sets, we don't want these two. So our final solution is pi and 6 and 11 pi and 6. Like, just follow these steps for now, yeah? Follow these steps for now, because once you get to a more complicated question, it will pay off.
Oh, sorry.
Which part? Yeah, go on.
No, she's saying that you know how you have negative pi and 6?
You could have just done 11 pi and 6, yeah?
Yeah.
And saved yourself the hassle. Yeah, you can do that. All right, nothing wrong with it. But what if your domain was different? It's just the standard. Why do we measure in radians instead of degrees? It's just the standard. Yeah. Like you'll start to see it once you get to this one here. Question 5. I'll do one from question 5. Since we've done cos, we'll do this one here. Does anyone have any questions so far? Which question would you like to do? A? Okay. Find all the values of x between negative pi and pi. So our domain is negative pi to pi. Now, have we seen this ratio before? What's this the same as? Have you done rationalizing? If I don't like the surd at the bottom, right? The surd is like the root 2. I want to get rid of it. So I'm going to multiply it by root 2. What I do at the bottom, I have to do at the top, right? So this ends up as 1 times root 2. Yeah. What happens to the square roots when they multiply? Yeah, they cancel out. The square roots cancel out, becomes a normal 2. We're more familiar with this on our hand, right? That's why I changed it. Take the cos across. Unit circle. Which finger do I have to put down? Which finger?
Middle.
Middle finger. Okay, cos goes towards the x-axis, right? We want √2/2. So that means we want to count 2 fingers. 1, 2, put this one down, that's pi/4. Cos has to be negative. Cos has to be negative. Which quadrants are we going to land in? S, that's one of them. What else? T, correct. Where are we going to pivot from? The right side or the left side? The right side or the left side? This side to get to here. The left side, right? So pivot. Here's your first solution. Pivot from here. Here's your second solution. Okay, just do whatever you used to, right? Just do whatever you're comfortable with. I'm not going to set the restriction of going from negative pi to pi. You do you. So if you're more comfortable with writing this as 5pi/4, then you go ahead and you do it. Sorry? Yes, absolutely. So you said, like, a lot of you are like, okay, I want to write this as, what's this? 4pi/4 here, yeah? So if I pivot backwards, I get 3pi/4. That's one of them. And if I pivot forward, this one becomes 5pi/4, yeah? So I've got my question? No? So what are my 2 base solutions? 3pi/4 and 5pi/4. Okay, ... because we haven't found all our solutions yet. What's our next part? Base solutions, check. Period. N equals 1. Two pi over 1. Do I want to rewrite that instead of 2 pi over 1? What fraction do I want it as? Pi/4. So what's that the same as? 8pi/4. Thank you. Modify the domain. It was negative pi to pi before. Negative 4pi/4. And positive 4pi/4. Okay, we've got our solutions now, yeah? I've got 3pi/4 as my first one. And I've got 5pi/4. Do I want to go forward? What happens if I go forward? That's 11pi/4, yeah? Check your gate, check your fencing. You know, where do you want to stop your fence? So we shouldn't have 11pi/4. And we shouldn't have 5pi/4, yeah? We should have less, right? Sorry? Yeah, well, isn't that the same thing that happened up here? We had negative pi/6. And that was past our fence. And that's fine. Yeah, you can just cancel it out and then pivot where you need to. So do we want to go forward in this case, or do we want to go backwards? Yeah, we don't want to go forward, so we try backwards, right? Let's go backwards. I'm going to ask you now, how do we go backwards? We have to subtract the period from which one? 3?
Then
5 pi and 4. You have to slinky backwards, yeah? You have to go to the previous one to get the next one. So subtract. So what does that give you? Should we go backwards one more? And if I go forwards, I'm just showing you here, yeah? If you go forwards, you get positive 11 pi and 4. That's out of the domain. That's out of the domain. Yeah, there's only 2 solutions. So my question to you then is it better to have it in between 0 and 2 pi? Notice here. Right? Or negative pi to pi?
I have no idea what you're trying to show me about, like, in this.
Yeah. Okay. So you want to switch it up? Okay. I just like to set the standard as negative pi to pi and then go from there.
Kidding you.
The difference is when you get to general solutions. Once you get to general solutions, it matters. And it will always go from negative pi to pi. Can I just get a one rating from 1 to 5? How confident you feel about this? A 1, 2, 0, 3, 4, cool. All right, 3, sorry, 3, 2, sorry. Ranking, 1 is good, 5, oh, sorry, 1 is I need to improve, 5 is like, I'm smashing this. 1. 1. How about you? 4. Oh, not bad. You need to rewatch the videos, try the questions again. Okay, we've got 6 minutes left. I've got time for another question. These are the ones, these are the realistic ones that you'll find.
Oh my gosh, bro. I didn't get it. I don't know if it exists.
Mian's gonna hear you laugh, and the whole class is gonna hear you laugh. No. Why would I edit it? You want to waste my time unless you want to edit it for me. You can be my unofficial video editor. I'm gonna do 7D here as the example. And then I'll actually throw a question at you that is actually realistic. I'm actually just gonna fly through this one so you can actually see how I work at speed. Okay, I'm not gonna explain anything. I'm just gonna fly through the question. Theta equals to is between, sorry, I'm just writing the domain here. 0 to 2 pi. Take the sign across first, it becomes sine inverse of, I'm just gonna rewrite this as negative root 2 on 2, because I know. Oh, I'm just talking myself. I'm a bit crazy like that, yeah. 1, 2, 3. I need sine to give me 2 fingers because I want root 2 on 2. So 1, 2, I put this finger down, that's my pi on 4 finger. My pi on 4 finger is the base angle. I know that sine inverse is going to give me some negative values. Negative, it's going to be in the C and the T quadrant. So I've got these two as my solutions. If I go from negative pi to pi, it's going to be negative 3 pi on 4 and negative pi on 4. So 3 theta is going to equal to negative 3 pi on 4 and pi on 4 as my 2 base solutions. I'm going to take divide everything by 3. Divide by 3. What happens on one side happens on the other. I'm going to get negative 3 pi on 12 and pi on 12, dot, dot, dot. Don't simplify this yet. The period is equal to 2 pi on n. Sorry, negative pi on 12. Thank you. Our n here, if I go back to the top, that's n equals 3. So we've got 2 pi on 3. However, I want to write that as pi on 12. So multiply the top by 4, multiply the bottom by 4. I get 8 pi on 12. That's my period. The domain as well is going to be 0 to 24 pi on 12. 0 to 24 pi on 12. So it's the same denominators across the board for these 3 sections here. Now I've just got to pivot into the domain. Now I can see those are negative. They're both sitting outside. So I just need to add the period to this one first. So that's, to this first solution here. So negative 3 pi on 12 plus 24 is 21 pi on 12. And I need to add the period. Oh my goodness. So sorry. I need to pivot this forward by adding the period, which is 8 pi on 12. Okay. Add by 8 pi on 12. So you get 5 pi on 12, which is our first positive solution because it's past 0. 5 pi on 12. Next one up is 7 pi on 12. From here, I can just look at this one and go, okay, plus 8. So that's 13. 7 plus 8 is 15. 13 plus 8 is 25. That's not in. So we remove that. Now, having a look at this here.
The 25.
Yes.
13 plus equals 2.
My bad. 21 pi on 12. Sorry, 13 plus 8 is 21. 15 plus 8 is then 23. 15 plus 8 is 33. Oh my goodness. All right, so we don't want to go any further. We have to simplify our solutions now. We've got 5 pi on 12. We've got 7 pi on 12, that you can't simplify those. You can't simplify 13 pi on 12. However, you can simplify this one by dividing top and bottom by 3. So we have 5 pi on 4. And we can divide top and bottom here by 3 as well. You get 7 pi on 4. The end. All right, so there we go. Sorry?
How did you get it?
Root 2 over 2. Rationalize. So this part here, I times the top and the bottom. So times the top and the bottom by root 2. 1 times root 2 at the top is root 2. Sorry, a second. And root 2 times root 2 is 2. So that's how I got that there. Okay, welcome. Make sure you get your practice in. This is an opportunity for you to practice your hand method as well. All right, thanks everyone. Bye.